Hey there. Tuples in Python are the same as lists, except that they are immutable. If you're not comfortable with the list data structure, please watch that video first before continuing with this one. You can initialize a tuple using parentheses or the tuple constructor. One small note is that if you're creating a tuple with only a single element, you do have to put a comma in there so Python doesn't confuse it with just a number. You can also convert other data structures like a list to a tuple using the tuple keyword. Similar to lists, you can have duplicate members in a tuple, and you can get the length of the tuple using the len function. And you can access different indexes in a tuple, which starts with index 0, and you can also count backwards from -1, which would be the last element, and -2 would be the one before that, and so on. Tuples only have a few built-in methods because all the methods that were designed to change elements in a list don't apply to tuples. The index method does the same thing as a list. It finds the first appearance of that element. So here orange is at index 1. And the count method counts how many times an element appears in that tuple. So here we have 2 apples, and we see number 2 down here. Similar to list, you have different ways of iterating over a tuple. You can create a while loop, you can count up manually, you can use the for in format, which I'm doing here, and just go over the elements of a tuple. Or if you need the indexes as well, you can use the for in with the enumerate keyword, which gives you the index as well as the elements in the tuple. So here I'm just printing out all the elements one by one from left to right. And here I'm doing the same thing, but with the indexes. Similar to list, you can also create slices from a tuple. Here I'm creating a slice with the indexes 0 and 1. Remember that we stop right before we reach the end index. And this doesn't change the original tuple. Another feature of tuple similar to list is that you can unpack the elements into variables. Here I'm unpacking these 3 elements in order to A, B, and C. So B here is now 2, A is 1, and C is 3. Now if you have different number of variables and elements in your tuple, then Python will give you an error basically saying that, I don't know where you would like me to put which element. Now one way to address this is you can use the star operator. So here, if I just put a star right before B, A is going to be assigned to 1, C is going to be assigned to 6, and the rest of these elements are going to be unpacked into B. So let's try this out. And if I print out B, now B is a list that contains all of this. In a list, we could update elements by accessing their index and providing a new value. In a tuple, that's not a supported operation because of its immutable nature. And when we say something is immutable, we're talking about the object. The references can still change. So here A and B are both pointing to this tuple that has 1, 2, and 3. So if I print them both, we see that they're both 1, 2, and 3. It doesn't mean that you can't change A and B. So here I'm changing A to point to a different tuple that has 4, 5, and 6. But the reason that we say it's immutable is that 1, 2, and 3 don't change. So that object is untouched. It's just that we are changing what A is pointing to now. And if B at some point points to something else and there are no more references to this old object, Python's garbage collector will go clean that up. But once we define this 1, 2, 3, or 4, 5, 6, it will never change to a different tuple. It either exists or at some point is cleaned up, but it will not change during its lifetime. One of the reasons that you would use a tuple instead of a list is for keys in a dictionary. A dictionary key has to be hashable, and only immutable data structures are hashable. So I would not be able to use a key, a composite key basically, using a list, but I can do it using a tuple, and I can access it same as any other data type. Another reason that you would use a tuple instead of a list is because of its immutable nature, it is more memory efficient. So when you're using a list, Python has to take into consideration that you may add elements to it. So there is some empty space allocated in case you want to increase the size of that list. But if you know your data structure will not change through its lifetime, it is more memory efficient to use a tuple because Python knows that's the size and it doesn't need to allocate any empty memory slots for that to change. Similar to list comprehension, you can also generate a tuple dynamically using tuple comprehension. Just one thing to note is that if you use parentheses alone, that creates something called a generator, which is a little bit beyond the scope of this video. So you need to put the tuple keyword behind it, which basically converts a data type into a tuple.